Welcome, it's Miss Skelton, and this video is going to help us finish out our unit about dividing polynomials. And so, if you're a fan of synthetic division, I'm hoping that you'll like this topic, because we're going to use synthetic division. Our goal today is to start with something that's quartic or cubic, like example 3 down here, and to be able to factor them completely and find all of the roots, whether the roots are real or imaginary, completely solve equations that are cubic and quartic. So we need to learn one final theorem in order to do this, and it's the rational root theorem. It states that a rational root, so rational is meaning it can be written as a fraction, so a rational root of a polynomial equation is of the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. Okay, what does that mean? So when we look at an example like number 1, we need to look at the constant term, so the term at the end that's just a number, and that is 6. So this whole p over q is that we're looking at the factors of the constant term 6. So think of all the numbers that go into 6. 1, 2, 3, and 6. And then q is a factor of the leading coefficient. So the leading coefficient, look at your highest powered term. Its coefficient is just a 1. And so what this is telling me is that the roots could be 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. And I know it doesn't say it here, but we actually need to include both positive and negative versions of these numbers. So we're going to use a plus or minus. So on your test, I'm going to have you list the possible roots. So let's actually list it out. Positive and negative 1 are possible roots. Positive and negative 2, because 2 divided by 1. Positive and negative 3 are choices from 3 divided by 1. And positive and negative 6. Now you might be saying, Ms. Skelton, why do I need to do this? Well, today I'm not going to tell you a root to start with. So I'm not going to give you a factor to divide by. I'm not giving you a starting point, and so to do this, you actually are going to need a pencil, because there's a good chance that we may not pick the exact right root and have to erase and try again. So if you need a pencil, check the basket on the bookshelf. Okay, so we just did step A, use synthetic division to determine which possible roots are actual roots. So I'm going to take our polynomial, 1x to the 4th, 1x cubed, negative 7x squared, negative 1x, and positive 6. And here's what I know. If it's going to be an actual root, I need to have a remainder of 0. That's the goal. So the 1 is going to be brought straight down, and we're going to have to try different numbers outside of our synthetic. So I usually start by trying positive 1. And there's no guarantee it's going to work. So let's see. 1 times 1 is 1, add straight down. 1 times 2 is 2, add straight down. 1 times negative 5 is negative 5, add straight down. Woo, we got lucky. 1 times negative 6 is negative 6. So what that tells me is that 1 is one of the final roots or solutions. So at the very end, I'm going to list all of the roots and the factors. So one root is positive 1. And think about what factor would that have come from? X minus 1. Okay, so this has helped me now reduce this down to a cubic function, 1x cubed plus 2x squared minus 5x minus 6. We need to repeat the same process for this cubic function. Okay, so we're going to do synthetic again to try to get it down to something quadratic that we can factor. So I'm going to set it up again. 1, 2, negative 5, negative 6. Bring the 1 straight down. I need a remainder of 0 at the end. And these are the numbers we're choosing from, right? This helps me because I don't want to choose 4 or, a half. Those are numbers that definitely won't work. After I try positive 1, I also like to try negative 1. If you'd rather try 2 or something else, that's fine. So I'm going to do negative 1, and let's see if it works. Negative 1 times 1 is negative 1. Add straight down. Negative 1 times 1 is still negative 1. Add straight down. Ooh, yay! Negative 1 times negative 6 is positive 6, and that works. So what I just found is that another root or solution is going to be negative 1. The factor that would have come from is x plus 1. And then I'm left with something quadratic. So from this step, I'm left with 1x squared plus 1x minus 6. And we actually now have to factor this to find any final factors and solutions, or factors and roots. So what multiplies to negative 6 but adds to 1? Let's see. Positive 3, negative 2. These are my final factors. And so then my two other roots would be negative 3 and positive 2. Okay, I realize that's a lot, and it's possible that these problems are frustrating if you don't pick the right numbers here. So we're going to keep using this theorem to help us list out the possibilities, and then we'll just keep going from there. It's going to take practice. Don't give up if you don't pick the right number right away. Just use an eraser and try again. Okay, the next one, honestly, if I saw this on a test, I would probably try to factor it first. But I want us to use this method just to make sure we have the hang of it. So let's list the possibilities. So plus and minus p over q. So look at your constant term of 18. So our possibilities, let's list all the numbers that divide evenly into 18, that are factors of 18. 1, 2, 3, not 4 or 5, but we have 6, 9, and 18. Q are the factors of the leading coefficient, so 1. So all my possibilities here are positive and negative 1, positive and negative 2, positive and negative 3, 6, 9, and 18. Okay, I'm going to get a scratch piece of paper because I want to show you what it looks like if you pick something that doesn't work. So I'm going to start my synthetic, and I'm going to use, let's see, 1x to the 4th, 0x cubed, negative 7x squared. So I need 2 zeros as placeholders in this problem. My goal is to get a remainder of 0, and I'm going to start by trying 1. 1 times 1 is 1. Add straight down. 1 times 1, add straight down. 1 times negative 6. And again, this does not create 0. So I'm using pen right now so that you can see this, but typically I just really lightly in pencil do this math until I get a remainder of 0. But unfortunately, I'm using pen. Okay, so let's try maybe negative 1. Right, you're just picking out of these possibilities. Negative 1, add straight down, add straight down. Ooh, not going to cancel out with negative 18. So negative 1 does not work. Let's move on to 2. This is the part that can be frustrating. Although on your test, I think there are only 2 problems where you have to do this. So it's not like the whole test will be this way. So I'm going to try 2 because that was one of the possibilities. 2 times 1, add straight down. 2 times 2, 2 times negative 3, and still a no-go. Okay, you can try negative 2. I have the advantage of knowing what works because I've already done the problem. So I'm going to have us use 3. So 1, 0, negative 7, 0, negative 18. Let's use positive 3. So 1 times 3, 3 times 3, 3 times 2, 3 times 6. Yay! Okay, remainder of 0. So what that tells me so far is that my factors, I just got 3. So one of the factors is x minus 3, and one of my solutions is x equals 3. We could say those are solutions or roots. And then I need to keep going. So I'm just going to line up another L underneath. I know this is cubic right now. 2 didn't work, 3 did. Since 3 was lucky, let's go ahead and try negative 3. So I'm now using these new numbers of my cubic function. Negative 3 times 1, add straight down. Negative 3 times 0, add straight down. Ooh, and negative 3 times 2 is negative 6, creating another remainder of 0. So let's see what we're left with. This here was 1x cubed once we divided 1 time. So now the degree has lowered again, and I'm left with x squared plus 2. No x term. Okay, well this definitely isn't factorable. So let's go fill in what we know so far. We have x equals negative 3 as a solution. So that comes from x plus 3. And then my other factors, if this is not factorable, then I just list that quadratic factor in my factors. And to get the solutions, I'm going to have to solve it. Set it equal to 0. X squared equals negative 2. So I'm going to have imaginary solutions here, because when I take the square root of negative 2, I'm getting both positive and negative. I'm going to bring an I out to show that it's imaginary, but I cannot simplify the square root of 2. So I do have 4 solutions. 2 are real, 2 are imaginary, and then I had 3 factors. 2 are linear, and 1 is quadratic that gave us those imaginary answers. Okay, well, this is the process we're going to keep using. So, of course, feel free to work ahead and check as you go. I'm going to keep going, and hopefully anything that's unclear will be clear after a couple more examples. Okay, so let's do this process again for number 3. It says complete each step to factor and solve 2x cubed minus 9x squared plus x plus 12 And this really should be an equation, so I'm going to make it equal 0. Determine all the possible rational roots. Okay, so here I'm going to put plus or minus, and then p over q. So think of the factors of 12, your constant term. 1 goes into 12, 2, 3, 4, 6, and 12. And then this is the first time that our leading coefficient wasn't just a 1. So the factors of 2 are 1 and 2. So I'm going to list out all the possibilities over here because there are more than we've had before. Each of these numbers would get divided by 1, so I'm going to do that. Let's see here. So plus or minus 1, 2 divided by 1, positive and negative 2, positive and negative 3, positive and negative 4, 6, and 12. But then I also have to go and divide each value by 2 and see if it creates another option. So 1 divided by 2 tells me that actually positive and negative 1/2 could be one of the solutions. 2 divided by 2 is 1, which I've already written. 3 divided by 2 would make another root. 4 divided by 2, 6 divided by 2, 12 divided by 2. Those values we've already listed with 2, 3, and 6. Okay, so again, that's a lot of possibilities. But let's start and see what we have luck with. So I'm going to get my extra piece of paper, just in case here. Two, -9, 1, and 12. The 2 I'm going to bring straight down. I usually always start with 1. Again, you don't have to. I usually do 1, -1, 2, and so on. So 1 times 2, add straight down, 1 times -7, and not going to work. Okay, so I'm going to move on to -1, and again, since I've previously done these questions, I have confidence that I could put this one on my paper. Okay, so now if I try -1, -2, add straight down, multiply, I get 12, and that's good because 12 plus -12 will leave me a remainder of 0. So we have found, remember this is actually a root or a 0 or a solution, so my factor would be x plus 1. And then my solutions, one of them is -1. And when I give you a cubic function, it's not as bad as the first two we did. Because when I divided by something with x, now this is quadratic. 2x squared minus 11x plus 12. So let's go ahead and see if it factors. That's why we've been working on factoring. So you have options. If you want to use grouping, I'll go ahead and put that in the video. So remember, we're doing first times last. This is only 3 terms right now, but I'm going to figure out what I could put in the middle instead of -11 to create 4 terms. So to do that, 2 times 12 is 24. So I'm thinking of the numbers that multiply to 24 but add to be -11. Looks like if I used 3 and 8 and made them both negative. The reason I sometimes write x squared here is to remind me that these terms are going to need an x on them when they get put in the middle because they're taking the place of -11x. They still multiply to make 24x squared, but when added, they make that -11. I'm going to put them in the middle. And now I have 4 terms to group. So the first group, I can take out an x, and I'm left with 2x minus 3. Second group, I have to divide by a negative. So negative 4 is the GCF, leaving me 2x minus 3. And now I can jump to my factors. The 2x minus 3 repeats. Awesome, we're doing it right. And then x minus 4 is our third and final factor. So my solutions, the x minus 4 creates a solution of positive 4. But make sure you don't go too quick on the 2x minus 3. When I set it equal to 0 and divide by 2 at the end, I'd get 3 over 2. So notice that all three of these solutions were in our original possibilities. Negative 1, positive 4, and positive 3 halves. Okay, we need to do more. And I know there are a lot of possibilities here that didn't get picked. Right? Because only 3 solutions are going to work when it's cubic. Alright, so let's try the next one. 4 says factor and solve. So one option is that with 4 terms, sure, you could try to factor by grouping, but I can already tell there's no way I'm going to be getting the same first and last term here. So let's list our possibilities. Our possible rational roots, all the factors of 4, 1, 2, and 4, divided by the factors of 8, 1, 2, 4, and 8. So that leaves me with, I'm going to divide each by 1, so positive and negative 1, positive and negative 2, positive and negative 4 from dividing each one by 2. Keep your list going because now I'm going to divide by 2. So that leaves plus or minus a half. 2 divided by 2 is 1. I don't need to rewrite it. 4 divided by 2 is 2. Don't rewrite it. Now divide all 3 by 4. So plus or minus 1/4. 2/4 is a half. 4 over 4 is 1. And then last one, plus or minus 1/8. Ooh. Okay, so in that case, I think that's the only new one created, because 2/8 would be a 1/4 and 4/8 would be a half. Okay, I promise I'm not going to give you one like this on a test because it doesn't really have many nice options. 2 of the answers, 2 of the solutions end up being fractions. So I'm going to help us get started. So I have 8, negative 38, 25, and negative 4. And I'm going to help you get started and tell you, let's start with a half. So bring that 8 down. A half of 8 is 4, and add straight down. Half of negative 34 is negative 17, and half of 8 is 4. Okay, so I'm left with 8x squared minus 34x plus 8. Okay, now notice though, I used a fraction here. So just like we've done with synthetic before, I actually have to divide this all by 2 because of the denominator of 2 here. And so it's leaving me 4x squared minus 17x plus 4. And this is what we would have to factor to get our final factors and solutions. So let's keep track of what we have so far. Factors, solutions. One solution is positive half. And think about what that looks like as a factor. If it got divided by 2, that means there was that 2 with x, and then we want the opposite sign of that solution. So using 2x minus 1 creates the solution of 1/2. You can do grouping again here. So if you do that, you're thinking to yourself, and again, a box works. You can guess and check. Whatever method you prefer, I am going to keep showing you grouping because it works, right? It's more steps, but it'll work every time if you get stuck. So 4 times 4, what multiplies to 16 but adds to the middle of negative 17? I need to replace the negative 17 with negative 16 and negative 1. So 4x squared minus 16x minus 1x plus 4. And then let's group it. Or put these in a box if you prefer. The first group shares 4x, leaving x minus 4. The second group doesn't share anything, so I'm going to divide by a negative 1 because of the sign in the middle. And it leaves x minus 4. So I found my other factors are x minus 4 and 4x minus 1, making my other solutions positive 4, add your 1, divide by 4, also 1/4. So again, I'm not going to give you one that has that many fractions on the test and make you, figure out to use a half or a fourth, but it's still good practice to see what would happen. Okay, on the next one, it says factor and solve, and I actually want to try, since this is a trinomial that looks like it's quadratic form, even though I know it's quartic, but it follows that same pattern of a quadratic trinomial, let's try factoring it. This one I don't have to group because it's an easy one that starts with 1x to the 4th. Okay, so I'm going to break this down. Instead of x to the 4th, I know that comes from x squared times x squared. And then think to yourself what multiplies to be negative 28, 1 times negative 28, but adds to be 3. Well, 28, what if we did 7 and 4, make the 4 negative? That works, and I can jump straight to my factors. I don't have to do grouping since this problem had a leading coefficient of 1. It's one of them that you are guaranteed to be able to do faster. Okay, now look and see. Can I keep going? I can here because I have the difference of perfect squares. So x squared plus 7. I can break this down into x plus 2 and x minus 2. So if it only asked for my factors, there they are. I have 3 of them. But since it wants me to actually solve, 2 of them are real solutions, negative 2 and positive 2, from setting each factor equal to 0. But when I set x squared plus 7 equal to 0, subtract 7, I have another imaginary solution. So you're going to show me that you got positive and negative when we take the square root of both sides of an equation. Show me it's imaginary by putting I square roots of 7. Okay, let's try another one and see what we think. Okay, I can see that it is quartic. So let's go ahead and start by listing our possibilities. Let me switch colors here. So all the numbers that are factors of 15, 1, 3, 5, 15. All the numbers that are factors of 2, 1 and 2. So that's positive and negative 1, positive and negative 3, positive and negative 5. So again, I'm just dividing each one by 1, and then a couple new ones are created. Actually, a lot of new ones are created when I divide by 2. So this one has possibilities of a half or positive and negative 3 over 2, positive and negative 5 halves, and positive and negative 15 halves. Okay, I'm going to try to see if pencil will show up on this video just so you can see kind of the process I go through. I mean, yeah, oh, that works fine. So 2, negative 1, 7, negative 5, negative 15. I want a 0 here, and then I usually really lightly start by writing a 1. So 1 times 2, 2, and I like write them kind of small and where they're going to be easy to erase if needed. 1 times 1 is 1. 1 times 8 is 8. Add straight down. Oops, positive 3. 1 times 3. Okay, I can see that's not going to work, but then I just have to erase these 4 and these 3 numbers. And then usually I leave the 1 here and I just try a negative, and let's do it again. So negative 2, multiply, I get 10. Okay, good. A negative times a negative, that's going to work. Okay, so far we've found that one solution is negative 1. Now I want to show you something else that you can try. So here I'm left with 2x cubed minus 3x squared plus 10x minus 15. If you get tired of guessing and checking, you can also think of the other methods we've learned for solving cubic functions. We reviewed factoring by grouping. So you could test out and see, does this work for factoring by grouping? Well, the first group shares x squared, and then I have 2x minus 3 left over. If I also get another 2x minus 3 over here, then we're golden. So the GCF is 5. Okay, excellent. That means this cubic function is factorable, and I don't have to do synthetic again. Now, you could do synthetic again, but you'd probably be working on it for a long time because of the solutions that we're about to write. So let's summarize what all we got. Our factors, we have 2x minus 3, x squared plus 5, and then the negative 1 is x plus 1. Then our solutions would be negative 1 that we know, set 2x minus 3 equal to 0 and get 3 halves, and then I'm going to get imaginary solutions again with the x squared plus 5 equaling 0. X squared equals negative 5, and take the square root of both sides. Those imaginary solutions come in pairs, plus or minus I square roots of 5. Okay. So I know this is taking a while. We have one more to do, and it actually is great because it's not one where we're going to have to guess and check of what to use. So this says determine the roots of this cubic function, and then it shows me the function. That's awesome. I can see one of the roots right away is negative 6. So one root is x equals negative 6. Now, here's the question. I don't see any other roots. So what does that mean? The other two roots are going to be imaginary. So you might say, let's just not find them then. Well, unfortunately, that's not an option. So we can use synthetic. 1, 11, 37, 42, and I can use negative 6 here because I know that it's a root that works. It's an actual root of this function. I don't have to use pencil. negative 6 times 5, negative 30, negative 6 times 7. Okay, great. I get x squared plus 5x plus 7. Now, I know it's not going to be factorable because the roots are imaginary. Nothing multiplies to 7 and adds to 5. Now, take a deep breath here. I'm not going to give you one like this on the test, but the only way to actually solve this, I'm not going to start singing because, you know, this is a video. I don't know how that would turn out. But it's the quadratic formula. So I'm going to do it just for fun. Okay, x equals opposite b, negative 5, plus or minus the square root of b squared minus 4 times a, which is 1, times c, 7, all over 2 times a. We know that we should get a negative under the square root because it's an imaginary solution. So negative 5 plus or minus the square root. What do I have? 25 minus 28. Oh, I probably don't need that big of a square root. So 25 minus 28 would be negative 3 all over 2 times 1. And thankfully, at least I didn't make it one where you have to do a lot of simplifying of your square root. Our final solution would be negative 5 plus or minus I square roots of 3 over 2. Okay, those are our two imaginary roots. The other one is this negative 6 here. So one real, two imaginary. Okay, so the work that you're going to be doing for me next is going to be better than this, than some of these really tricky ones. You're going to practice listing out your possible roots and then going ahead and using synthetic. So have a pencil on hand. You may have to erase if you don't pick the right one. The goal is that we get it completely factored and find our solutions. And y'all, I'm pretty sure that this doesn't even have anything imaginary on it. So use this as a way to check and see, do you understand the process of starting with something cubic or quartic and using synthetic to get it all the way factored and solved. Okay, we're going to be reviewing when we get back from the break, so you can already take a look at that review if you want in Canvas, and we'll put it all together after. I hope that y'all have an excellent break, and I'll see you when we get back.